Okay, let's take a look at our last two problems here on our review. It says here in problem 18, an airplane takes off at a speed, s, of 295 miles per hour at an angle of 17 degrees with the horizontal. Resolve the vector s into components. So we're going to look at the components that are formed from this vector here. So we've got this velocity vector, the speed of the airplane here. So let's draw a picture of that. So again, the speed, the magnitude is 295 miles per hour. Direction is 17 degrees off the horizontal. So let's go ahead and draw that in. So we were drawing in, here's our horizontal. We'll go 17 degrees off that. And we're going to draw in this vector. Okay. Here's this directed line segment. Here's the vector S. This is 295 miles per hour. Now as we resolve it into its components, let's look. So we're going to look at the horizontal component, the horizontal distance traveled, and the vertical distance traveled. So there are the two components. Now remember our angle, let's go ahead and label that. This was a 17 degree angle off the horizontal. So we got 17 degrees here. With that said, if we want to find the components, let's go ahead and label them. So here's our horizontal component, HC. We'll call that, I'm going to give it a name, vector U. And our vertical component, we'll call that vector V here. So we'll call that V. So there are two components. So looking at our horizontal component. So again, a horizontal component in this problem, I've gone ahead and labeled as U. So to find U, how do we find U? So again, what do we have in this drawing? We have a right triangle. So we can use our definitions, right? We know cosine. If I ask you what's the cosine of 17 degrees, you would tell me it equals U divided by 295, right? The adjacent side over the hypotenuse. So using right triangle trig here. So let's go ahead and solve that. So we're going to solve for U. We go ahead and multiply both sides by 295. Right? So what is that going to end up giving us? So that implies U is equal to 295 times the cosine of 17 degrees. So let's go ahead and see what that is. Let's resolve it. So let's put that in our calculator. So as we go to our TI, we got 295 times the cosine of 17 degrees. I got 282.1. So as our vector goes, this is 282, right, mph, miles per hour. There's our horizontal component. There's HC. All right, let's do the same thing for vector V. So what does V equal? So our vertical component, I'll go ahead and show our work here with it. And our vertical component we've labeled V. And to find V, we can use the definition of sine, right? We know the sine of 17 degrees equal to opposite V divided by hypotenuse, 295. So again, definition, opposite over hypotenuse. And as we're solving that, right, we'll go ahead and clear out the fraction. Let's go ahead and multiply both sides by 295. And as we simplify down, we have V, our vertical component, equal to 295 times the sine of 17 degrees. Let's go plug that in and see what we come up with. What's 295 times the sine of 17 degrees? We get 86.2. So this is 86 miles per hour as we round to the nearest mile per hour, the nearest whole number. But there's vector V. Right, there's our vertical component. So we resolved that into components, right? Our horizontal and vertical component. Our horizontal and vertical distance. Those are the lengths of those two vectors. So we've labeled the three sides of that right triangle. So again, use some right triangle trig to help us. In our next problem, which is our last problem, it says find the component form of a vector given the initial and the terminal points. So I want to find the component form. Now, component form, go ahead and write that up here. Component form is equal to horizontal component and vertical component. That's component form. Now let's go ahead and get a picture of vector AB. So let's go ahead and draw in a picture of what we have here in front of us. Let's draw in this directed line segment. So with A, all right, we got a starting point of -2, -1. So here's our initial point. All right, -2, -1, there's A. And B, the terminal point, right 3, up 4. We're in quad 1 with our terminal point. 3, 4, there's B. But here's our directed line segment. There's vector A, B. Now, as we resolve that into components, let's look at it. So what's our horizontal and our vertical distance? What are we traveling here, horizontally and vertically? So there's our horizontal component, HC. I'll label that U. Here's our vertical component, right here, V. We'll call it. Well, what is that? So we can find that easily. So given our x coordinates, we know our horizontal component is going to be equal to x2 minus x1, the horizontal distance. 3 minus -2, which is 3 plus 2, or 5. So we've gone 5 units to the right. And our vertical component, well, that's going to equal what? That's going to equal y2 minus y1, right? 4 and -1, which is equal to 4 minus -1, which is 4 plus 1, or 5. So we went right 5 units, and we went up 5 units, right? -2 over to 3 is 5 to the right. And vertically, we went up 5. We went from -1 y-axis to 4. So our component form, right, we've got our horizontal component. They're both 5 units, 5 to the right and 5 up. So our horizontal and vertical distance. So there's the component form for our vector. So finding that horizontal and vertical distance, right? That's our horizontal and vertical component.